Good morning everyone, welcome back to the 13th session. In the previous session, we learned how to find the adjoint of a matrix. So in today's session, we will learn how to find the inverse of a matrix. The procedure is same as adjoint of the matrix. However, there is only one step extra, that is you are supposed to put the inverse formula and then solve the problem. So before that, let me tell you about the inverse of a matrix. Consider a matrix A. The inverse of a matrix is denoted by A inverse and is defined as A inverse is equal to 1 by determinant A into adjoint A. Let me quickly summarize how to find adjoint A for a 2 cross 2 matrices. Change the principal diagonal elements, interchange the principal diagonal elements, change the sign of the other elements. Then how do you find cofactor matrix? Cofactor matrix is defined as Aij and is given by Aij is equal to minus 1 to the power I plus j into Mij. So to start off with the first problem, find the inverse of the following matrices. What is the formula to find the inverse of the following matrices? We know that A inverse is equal to 1 by determinant A into adjoint A. So first step, let A equal to, sometimes it is defined as A equal to, otherwise we need to define let A is equal to 2, minus 2, 4 and 3. Next, what is the formula for inverse of a matrix? A inverse is equal to 1 by determinant A into adjoint A. So we shall find the value of determinant A. How do you find the value of determinant A? Product of the principal minus product of the secondary. What is product of the principal? 3 2s are 6. Formula is always with minus. 4 into minus 2, minus 8. Minus into minus will become plus. So what is 6 plus 8 sums up to 14. Now next, adjoint A. How do you find adjoint A? Interchange the principal diagonal elements, change the sign of the other elements for a 2 cross 2 matrix. So interchange the principal diagonal elements. These are principal diagonal elements which has to be interchanged. So this becomes 3 and this becomes 2. Change the sign of the other elements. If it is positive, make it as negative and vice versa. So here it is minus 2, so this will become plus 2. Here it is 4, this will become minus 4. Now, what is the formula for inverse of a matrix? We know that inverse of a matrix is given by A inverse is equal to 1 by determinant A into adjoint A. So what is the value of determinant A? That is nothing but 14 into what is adjoint A? 3, 2, minus 4 and 2. This is the final answer. This can also be written as, proceeding to one more step. You can stop till here or you can proceed, which can be written as 3 by 14, 2 by 14, which will sum up to 1 by 7 for the simplification, minus 4 by 14 for the simplification, minus 2 by 7, and this is again 2 by 14, which is equal to 1 by 7. This is nothing but A inverse. Further you can simplify 1 by 7 minus 2 by 7, again 1 by 7. Moving on to the second problem now. The elements are minus 1, 5, minus 3 and 2. So first step, let A is equal to minus 1, 5, minus 3, 2. Then how do you find determinant A? Product of the principal minus 2. The formula is with minus. Minus into minus will become plus. So 5 into minus 3, minus 15, minus into minus will become plus. So what is 15 minus 2? 13. Next, how do you find adjoint A? Change the principal diagonal elements, change the sign of the other elements. These are principal diagonal elements. You are supposed to interchange. So this becomes 2, this becomes minus 1. Change the sign of the other elements. Here it is plus 5. So if you change the sign, it becomes minus 5. Here we have minus 3. Changing the sign, it becomes plus 3. What is A inverse given by? We know that A inverse is equal to 1 by determinant A into adjoint A. So A inverse is equal to, what is determinant A? 1 by 13. What is adjoint A? 2, minus 5, 3, minus 1. This is the value of A inverse. Moving on to the next problem we have. A equal to, the elements are 3, 1, minus 1, 2. First we shall find the value of determinant A. Product of the principal, that is 6. Followed by the formula, it is a minus sign. Minus 1 into minus 1, it will be plus 1. 6 plus 1 will be 7. How do you find adjoint A? Interchange the principal diagonal elements, change the sign of the other element. So this is 2, 3, 1 plus 1 will become minus 1, minus 1 will become plus 1. How do you define A inverse? 1 by determinant A into adjoint A. So what is determinant A? 7. That is 1 divided by 7 into. What is adjoint A? 2 minus 1, 1, 3. You can stop at this step, or further if you want to simplify, you can simplify. 2 by 7 minus 1 by 7, 1 by 7 and 3 by 7. This is the required answer. Next problem. If A is equal to 3, 7, 2, 5, find AB the whole inverse. If A equal to and B equal to. If A is equal to and B is equal to, find the value of AB inverse. So what is the value of B? 6, 8, 7, 9. 6, 8, 7, 9. If A is equal to 3, 7, 2, 5, B is equal to 6, 8, 7, 9, find the value of AB whole inverse. First we will find the value of AB by matrix multiplication. What is A? 3, 7, 2, 5. What is B? 6, 8, 7, 9. So finding the value of product AB. You will multiply row wise, you will multiply column wise with the corresponding element. 3 into 6, 18 plus 7 7s are 49. 3 8s are 24. 7 9s are 63. Similarly, 2 into 6, 12 plus 35. 8 2s are 16 plus 5 9s are 45. So what is AB now? 49 plus 18. 67. Similarly, 87, 47 and 61. This is AB. Now we shall find adjoint AB. How do you find adjoint AB? Interchange the principal diagonal elements, change the sign of the other elements. That is 61, 67, minus 87, minus 47. This is adjoint AB. Now, how do you find determinant of AB now? Determinant of AB, that is 67 into 61 minus 47 into 87 will sum up to minus 2. How do you define AB the whole inverse? 1 by, in general, how do you define A inverse? 1 by determinant A into adjoint A. So with respect to AB whole inverse, 1 by determinant of AB into adjoint AB. So what is determinant AB? 1 by minus 2. What is adjoint AB? 61 minus 87 minus 47 and 67. This is the required answer. Moving on to the next problem, we shall find the inverse for a 3 cross 3 matrix. Now, for the matrix A equal to 1, 1, 1, 1, 2 minus 3, 2 minus 1, 3, find A inverse. The procedures are the same. First we will find minus denoted by Mij, then we shall find cofactors denoted by Aij. We will write the cofactor matrix. Transpose of cofactor will become what? Adjoint of a matrix. The only one step here we are supposed to find is determinant A. Determinant A, to find the determinant A, we have to associate the signs for a 3 cross 3 determinants, that is plus, minus and plus. Expand the determinant or there is one more formula to find the value of determinant A. So, we shall solve this problem now. Minors and this is cofactors. What is cofactors denoted by? A of ij is equal to minus 1 to the power I plus j into mij. So, we shall start finding out the cofactors now. M11, which is M11, that is nothing but 1. You are supposed to leave the row containing 1 and the column containing 1. So, what is the elements left out? 2, minus 3, minus 1, 3. Product of the principal minus product of the secondary. So, 6 minus 3 will be 3. Similarly, M12, which is M12, that is nothing but 1 again. So, we are considering first row, second element. Leave this row, leave this column. So, what is left out? 1 minus 3, 2, 3. 1 minus 3, 2, 3. This is 3 plus 6, which is equal to 9. Product of the principal minus product of the secondary. Since we have a negative sign, it becomes positive. Next, M13, which is the element we are considering here, 1. Supposed to leave that row and that particular column. What is left out? What are the elements? 1, 2, 2, minus 1. This will be minus 1, minus 4. It will be minus 5. This is M13. Simultaneously, we can find Aij, or you can finish finding the elements, minor elements, then you can start off with cofactors. So, simultaneously solving, what is A11? Minus 1 to the power 1 plus 1 into 3. That is nothing but 3. What is A12? Minus 1 to the power 1 plus 2 into 9 minus 9. What is A13? Minus 1 to the power 1 plus 3 into, what is M13? Minus 5. This will be minus 5. This is all about M1, M11, M12, M13. Now, we shall find out M21, M22, M23. Which element are we speaking about when I say M21? That is nothing but second row, first element, 1. Supposed to leave that particular row and that particular column. What are the elements left out? 1, 1, minus 1, 3. 1, 1, minus 1, 3. So, 3 plus 1 will be 4. What is cofactor of A21? Minus 1 to the power 2 plus 1 into 4 will be minus 4. Similarly, M22, which element are we speaking about? M22, second row, second element, that is 2 equal to. When I consider this 2, you are supposed to leave this row and this column, complete row and complete column. What are the elements left out? 1, 1, 2 and 3. 1, 1, 2, 3. 3 minus 2 will be 1. Similarly, M23, which is the element of M23, minus 3. When you leave minus 3, this row and this column, minus 3 row, minus 3 column, 1, 1, 2, minus 1, 1, 1, 2, minus 1, minus 1, minus 2, minus 3. Similarly, we shall find out what is A22. What is A22? Minus 1 to the power 2 plus 2 into 1 will be 1. What is A23? Minus 1 to the power 2 plus 3 into minus 3. That is nothing but plus 3. Now, we shall find out M31, M32 and M33. M31, M32 and M33. What is the element of M31? That is third row first element. That is nothing but 2. So when you consider 2, what are the elements you are supposed to leave? The element containing 2 row and 2 columns. That is 1, 1, 2, minus 3. 1, 1, 2, minus 3, which will sum up to minus 3, minus 2, minus 5. What is M32? That is the element, third row second element, minus 1. What is the element left out? Minus 1 through minus 1 column, 1, 1, 1, minus 3. 1, 1, 1, minus 3. Minus 3, minus 1, minus 4. Similarly, M33, that is 3. 1, 1, 2, 1. 1, 1, 1, 2. So it is 2 minus 1, 1. How do you find A31 now? Minus 1 to the power 3 plus 1 into minus 5 will be minus 5. A32 minus 1 to the power 3 plus 2 into minus 4 will be plus 4. Minus 1 to the power 5 minus 1, minus 1 into minus 4 plus 4. Similarly, A33 minus 1 to the power 3 plus 3 into 1, minus 1 to the power 6, 1, 1 into 1 will be 1. We finished finding out the minors and cofactors of the given matrix. Now, we shall write the cofactor matrix. We shall write the cofactor matrix. What is cofactor matrix given by? 3, 9, 3, minus 9, minus 5. 3, minus 9, minus 5. Similarly, minus 4, 1 and 3. Minus 4, 1 and 3. Minus 5, 4, 1. Minus 5, 4 and 1. This is cofactor matrix. How do you find adjoint of a matrix now? Transpose of a cofactor matrix will be adjoint of a matrix, which is given by 3 minus 9 minus 5 minus 4 1 3 minus 5 4 and 1. Minus 4 1 3 minus 5 4 and 1. Now we are supposed to find inverse of a matrix. How do you find inverse? How do you define inverse? 1 by determinant A into adjoint A. Determinant A, one method of solving, I have showed it in the previous sessions. You are supposed to associate the sign for the first row, expand the determinant. Or one more method. How do you find adjoint A? Sorry, determinant A? A11 into A11, element into cofactor, plus A12 into A12, A13 into A13. Determinant A. What is A11 element? That is nothing but 1. 1 into, what is the value of A11? That is nothing but 3. Which is A12 element? 1 again. What is the value of A12? Minus 9. Again, A13, 1. What is the value of A13? That is nothing but minus 5. So what will this sum up to? 3 minus 9 minus 6 minus 6 minus 5 minus 11. So A inverse is given by 1 by minus 11 into, what is adjoint A? 3 minus 4 minus 5 minus 9 1 4 minus 5 3 and 1. This is the required answer, or you can divide each element by minus 11. You can stop till here, or you can divide each element by minus 11. Moving on to the next problem we have. A is equal to 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. The procedure is the same. First we shall find all the minors, then we shall find all the cofactors. So what is M11, which is the element M11 2? So What are the elements left out? 2 minus 1, minus 1 and 2. Similarly, what is M12 minus 1? Supposed to leave this row, second column. Minus 1, 1, 2. Minus 1, 1, 2. M13. What is M13? 1, which is equal to minus 1, 2, 1, minus 1. M13. What is M21? That is, we are considering minus 1, which is equal to, leave this row, leave this column. Minus 1, 1, minus 1, 2. Minus 1, 1, minus 1 and 2. Simultaneously, we shall find A11. What is A11 given by? In general, what is Aij? Minus 1 to the power I plus j into Mij. So, what is A11? Minus 1 to the power 1 plus 1 into, what is the value of M11? 4 minus 1, that is nothing but 3. So, into 3 will sum up to 3 again. What is the value of M12? Minus 2 plus 1 will be minus 1. So, what is A12? Minus 1 to the power 1 plus 2 into minus 1 will be plus 1. Similarly, what is the value of M13? 1 minus 2 minus 1. What is the value of A13? Minus 1 to the power 1 plus 3 into minus 1 will sum up to minus 1. M21 answer, minus 2 plus 1. Minus 2 plus 1 will be minus 1. So, what is A21? Minus 1 to the power 2 plus 1 into minus 1 will be plus 1. Next, we shall find out M22, M23 and so on up to M33. What is M22? That is, we are speaking about second row, second element, that is 2. So, you are supposed to leave this row and second column. What are the elements left out? 2, 1, 1, 2. 2, 1, 1, 2. What is M23? Minus 1. Second row, third column. You are supposed to leave second row and third column. 2 minus 1, 1 minus 1. 2 minus 1, 1 minus 1. That is M23. 2 minus 1, 1 minus 1. Similarly, M31, that is 1, which is equal to minus 1, 1, 2 minus 1. What is M32? Minus 1. We are considering this element. So, leave this row, leave the second column. What is left out? 2, 1, minus 1, minus 1. 2, 1, minus 1, minus 1. What is M33? That is the last element. 2. 2 minus 1, minus 1, 2. 2 minus 1, minus 1 and 2. So, we shall find out. 4 minus 1, 3. Minus 2 plus 1, minus 1. 1 minus 2, minus 1. Minus 2 plus 1, minus 1. Minus 2 plus 1 will be minus 1. 4 minus 1 will be 3. Similarly, what is A22? Minus 1 to the power 2 plus 2 into 3 will be 3 itself. A23, minus 1 to the power 2 plus 3 into minus 1 will be plus 1. Minus 1 to the odd power is minus 1. Minus 1 into minus 1 will be plus 1. Similarly, what is A31? Minus 1 to the power 3 plus 1 into minus 1 will be minus 1 again. Minus 1 to the even power 1. 1 into minus 1, minus 1. A32, minus 1 to the power 3 plus 2 into minus 1. So, minus 2 plus 1 will be minus 1. Minus 1 into odd power, minus 1. Minus into minus, plus. A33, minus 1 to the power 3 plus 3 into 3 will be 3 itself. that is M33. Simultaneously, now we shall find out determinant A as well. How do you find determinant A? A11 into A11, element into cofactor, plus A12 into A12, A13 into A13. What is A11 element given in the matrix? 2. What is the cofactor of A11? That is nothing but 3. What is A12? Minus 1. What is cofactor of A12 will be plus 1. What is A13? That is the third element, 1. What are the cofactor of A13? Minus 1. This will sum up to 6 minus 1, 5. 5 minus 1 will be 4. Cofactor matrix. Cofactor matrix. What is cofactor matrix? 3, 1, minus 1, 3, 1, minus 1, 1, 3, 1, 1, 3, 1, minus 1, 1 and 3, minus 1, 1 and 3. This is cofactor matrix. How do you find adjoint matrix? That is nothing but adjoint A, cofactor of the matrix A or adjoint of the matrix A. 3, 1, minus 1, 1, 3, 1, minus 1, 1 and 3. How do you define A inverse? 1 by determinant A into adjoint A, which is equal to, what is determinant A? 1 by 4. 1 by 4 into, what is adjoint A? 3, 1, minus 1, 1, 3, 1, minus 1, 1 and 3. This is the required answer. Moving on to the next topic in this chapter is application of determinants and matrices. Here we will study what is consistent and inconsistency system. After that, we shall solve few problems based on matrix method. So, consistency and inconsistent system. A system of equation is said to be consistent only if its solution exists, and in case if its solution does not exist, it is said to be inconsistent. Then, solution of system of linear equation by using inverse of a matrix. Consider the system of equation, that is a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x b3y plus c3z equal to d3. Here, let the matrix A contains the elements of, that is a1 b1 c1, a2 b2 c2, a3 b3 c3, and x contains the coefficients of the elements, that is nothing but x, y and z, and d is the constant which is on the RHS, that is d1, d2, d3. Here we shall discuss two cases. Case 1, if A is a non-singular matrix, then its inverse exists. What do you mean by non-singular matrix? When do we say matrix is singular? If determinant A equal to 0, then it is said to be a singular matrix. Consider Ax equal to D. You will pre-multiply by A inverse on both the sides. A inverse into X equal to A inverse into D. Grouping the terms, what is A inverse into A? That is nothing but I. Matrix and its inverse is equal to I. Identity matrix into any term is the same matrix. So, RHS remains the same, which is given as X equal to A inverse into D. This matrix provides unique solution for the given system of equation, as inverse of a matrix is always unique. This method of solving the system of equation is known as matrix method. This is all about case 1. So, we shall discuss about case 2 in the next session. Meanwhile, in case if you have any queries in today's session, you can upload those queries in the prescribed link. So, with this I have come to an end in today's session. Thank you.